Hi guys, so today we're going to be working with rotational symmetry, and the first activity is actually combining reflectional symmetry and rotational symmetry, but I just want to demonstrate rotational symmetry for you since we already looked at reflectional symmetry. So I actually have some tracing paper. So guys at home, you might want to have some wax paper or some tracing paper or any kind of paper that's a little bit translucent so that you can actually see what's going on here. But rotational symmetry is basically when you take a shape and you turn it upon itself, and you want to see how many times the shape is going to actually map onto itself and see how many times that happens, and that's what rotational symmetry is. So I've actually traced the first figure, and I actually just marked the first vertice at the top A just for a reference point to see how many times that this figure would actually map upon itself. So if we take a look here, I'm going to do a quarter turn to the right, or a 90-degree turn, and see. You can see that that's not going to map on itself at all. Now I'm going to do another 90-degree turn, so I'm totally at 180 right now. So again, not mapping on itself. Another 90, so that would put me at 270, not mapping on itself. And then finally, I'm back to where I started from. Now I have mapped onto myself, but it has taken the full 360 degrees. So I've only mapped onto myself one time, okay? So it only happened once. The formula is you take the total amount of rotations that you have in a circle, which is 360 degrees, and you divide that by the number of times that it would map onto itself. So in this particular shape of rotational symmetry, we only had it map onto itself one time. So we would do 360 divided by 1. So in terms of the degree of rotation, in terms of rotational symmetry, this would be 360 degrees because it would be 360 divided by 1.